So we're here to talk about a recent performance benchmarking test that Overture performed with a number of our industry partners. As shown here on this placard, this test was conducted in collaboration with Intel, with Brocade, with Spirent, and in an effort to make sure that this was really following real-world types of requirements and performance characteristics. We invited one of our carrier partners to provide requirements around how this would actually run in a real-world environment, and also to validate the results at the end. So this test, the importance of this test is that we were able to show multi-vendor VNF service chain orchestrated through centralized orchestration and running high-performance, zero packet loss type of throughput characteristics on a single low-end cost server platform. So this hardware rack right here actually gives an example of how this test was conducted a couple of weeks ago. And here on the top, again, this is a standard commercial off-the-shelf low-end server platform running our network service orchestration platform called Ensemble Service Orchestrator, or ESO. Down here, each of these two nodes are, again, very similar types of hardware platforms running a mirror copy of the same setup that we did the performance benchmarking on. So on this single server platform, we're running, I believe, 3 independent VNFs, all running on the same chassis. The first VNF has our Ensemble Carrier Ethernet virtual network function, which provides Layer 2 virtual network interface device, as well as an accelerated virtual switch. And that provides the foundation upon which all of the other third-party VNFs run. And then on top of our Ensemble Carrier Ethernet VNF, we're also running a Brocade virtual router, as well as a Spirent virtual test head. And in this scenario, these virtual network functions are orchestrated by our ESO platform, and the Spirent virtual test head is responsible for generating the traffic from end to end. Now this box down here is essentially running the same thing, and we have these two communicating to one another. So this third box down here is Overture's internal vCPE platform. Essentially, the internals, the processing capabilities, are the exact same as these commercial off-the-shelf boxes. All these are running Intel's Atom C2000 processor, so it's more of a mid-range processor in a more cost-effective server platform. The difference between this one and these other two is that Overture's provided some telco-grade hardening, Wi-Fi, wireless backup capabilities, some expansion slots to run some additional functions on the box. But we wanted to conduct this test on what would be essentially just a standard mid-range commercial off-the-shelf hardware platform. So this setup right here kind of reflects the actual test scenario that we ran about 2 weeks ago in this performance benchmark. So the challenge that we were trying to address with this proof of concept was to demonstrate that we could, with a low-end, low-cost server for a virtual customer premise equipment type of use case, still achieve line rate throughput on a multi-gigabit interface with zero packet loss, low latency, and no delay. And so that's the type of test that we ran. We also did this through a multi-VNF chain. So not just running a single VNF, but we were able to run our VNF chained with 2 other third-party VNFs and still achieve that multi-gigabit line rate throughput with zero packet loss. Within this proof of concept, Overture's primary role was, one, to get this all coordinated. It's a number of our Harmony ecosystem partners that we brought to the table to actually run this test with us. But specifically from a product side, we contributed a couple of components. One was our Ensemble Service Orchestrator, or ESO, which was responsible for orchestrating not only our own VNF, but the third-party VNFs that we put in service chain to run this end-to-end benchmark test. The other important part that we brought to the table was our Ensemble Carrier Ethernet virtual network function, which provides a virtual NID, or network interface device, capability for layer 2 connectivity, as well as an accelerated V-switch. So in the service chain, all of the traffic was passing through our ECE VNF, both natively as well as switching that between the different VNFs and chains. So that was kind of really the underpinning of the performance test, was also on our VNF. Within a multi-VNF chain, we were able to demonstrate that we could get 2 gig line rate throughput with iMix traffic profile, which is a standard, typical internet frame size, or frame size for internet traffic mix. And we were able to do that with a multi-VNF chain with, again, zero packet loss, extremely favorable latency and delay characteristics. So, from the standpoint of being able to run end applications on top of that, networking connectivity, we were able to demonstrate that you could really do that in a low-end cost box. We're engaged in a number of operator trials and proofs of concept today, not only in the US but also globally. There is a lot of interest in these virtual CPE solutions around the world. So we're excited about that because we have a number of customer engagements going on right now and actually more lined up behind it. From a going live perspective, the business cases are actually bearing themselves out right now. But one of the big conversations that we're having with our customers is talking about the total cost of ownership. So as we're also doing the technical validation of this, we're also validating the business case for it. And as those things really start to come together, and we're seeing that happen right now, we're expecting this solution to actually start rolling out later this year. The next steps for this solution would be to continue expanding on our performance benchmark, bringing in additional VNF partners, and validating some of the unique customer use cases in the VCP environment, and then also taking that information, building it into a TCO model that we're continuing to work with our customers to demonstrate the real value of this solution and ultimately take it to market later this year.